Okay, we're looking at uniform distribution. It says, suppose the time it takes my daughter Lizzie to eat an apple is uniformly distributed between 5 and 10 minutes, and let x, the random variable x, equal the time in minutes it takes Lizzie to eat an apple. Make sure you read section, let's see, it's 5.1, 5.2, beginning the continuous probability distributions. So, first of all, it's a continuous distribution. Recall that we just finished binomial, and it was a discrete distribution. That means things were countable. Recall the different types of data types. You had your continuous data type, and you had discrete. And you could determine whether one was discrete or not by simply saying the number of. So, the uniform is continuous, and that means the data in there is usually something that can be rounded. So, this is time. So, so theoretically, the first question, let's just say B, less than 4 minutes. C is 6 minutes, and then goes down to D, 5.2 to 7.1 minutes. These are rounded numbers. Really 5.2 minutes could be 5.2, 6, 4, 7, 8, 9, ever how many decimal places you wanted to round it to, and it'd be an infinite number. So the notation for the uniform distribution, continuous distribution, is x is a random variable, such that is uniform A, comma B, where A is the lowest value of x and B is the highest value of x. And it's pretty simple. It's not that hard. I think the first question gave you a pretty good video on what you're doing, but you're just going to be shading basically a rectangle and finding the area of that. One thing I want to point out that I don't know that your book does or not is that, remember, in a discrete distribution, the probability that x is less than 4 is different than the probability that x is less than or equal to 4. Okay, those are two different things, and I just made the 4 up. It could be any number here. In a continuous probability distribution, this doesn't matter. So the probability that x is less than or equal to some number is the same as the probability that x is just simply less than that number. So less than and less than or equal to makes no difference in a continuous probability distribution. And the same thing for greater than. I could have said the probability that x was greater than or equal to some number, 5, we'll just put an example, 5 here, will be the same as the probability that x is greater than 5. Again, greater than or equal to and greater than are going to be the same thing. Less than or equal to and less than are the same thing in a continuous probability distribution. So, point that out. So, the first thing we're going to do is draw this thing out. Go on here. Not very good, obviously. So, what are my endpoints? Okay, it's between 5 and 10. And I'm just going to... Obviously, I'm not going to be drawing this to scale. I'll put a 5, 6, 7, 8, 9, 10. Because, if we were drawing this out in a true graph, we would need a 0, and these would need to be, equidistant. I'm just doing this for all you have to do to solve the problem. So, we need to find the difference between 10 and 5. So, 10 subtract 5 is equal to 5. So, that tells me up here, this is going to be 1 over this difference. Okay, so I'm going to draw this out because the area underneath this thing has to be equal to 1. Okay, so the area under this entire thing if I was to shade all of these, 1, 2, 3, 4, 5, so there's 5 of them. 5 times 1/5 is 1. There you go. So let's look at what we got here. So we know that it's uniform. with a 5 and a 10. What's the probability that it takes Lizzie less than 4 minutes? So this would be B. The probability that X is less than 4, and it's the same thing as the probability that X is less than or equal to 4. It doesn't matter. Okay, well, 4 is not even in here. So that's going to be 0. Going to C. The probability it takes Lizzie at most 6 minutes. So at most 6 minutes. How would I write that? Probability at most 6 would be, and their data set would be 5 or 6. So we'll just say that X is less than or equal to 6. Okay. So that's going to be, we need a 7 here. So it's really just going to be this one here between 5 and 6. So there's one of those. So it'll be 1 times 1/5. So equal to 1/5. C, D. Between 5.2 and 7.1. Well, 5.2 would be about here. And 7.1 would be right here. So let's see. But let me just write this down. So probability that 5.2 is less than or equal to X is less than or equal to 7.1 again. Less than or equal to. It doesn't matter. Let's find the difference between these two. So 7.1 subtract 5.2. Okay, so then it's going to be just simply the 1/5 times the 1.9. So that would be simply taking the 1.9 dividing it by 5.38. And E, fewer than 5.2 minutes or more than 7.1. Okay, fewer than 5. Let's find this one up here. Then equal to, or 5.2. Okay, well, we're just simply going to subtract. So we're fewer than 5.2, so that's going to be, your endpoint is 5, so 5.2 minus 5, that's simply equal to 0.2. So your answer is going to be 1/5 times 0.2. 2 divided by 5, which is equal to 0.04. We've got an OR in here. Probability more than 7.1. X is greater than or equal to 7.1. So again, 7.1, and you would shade it to the right. So to get this area here, you would take the 10, subtract off the 7.1. Okay. And that's 2.9. So we'll take the 1/5 times the 2.9. So let's divide that by 5.58. So, and since this is an OR, I'm going to be taking these two and adding them together. Or more than 7. Okay, so I got the 0.58 in there, plus 0.04 equal 0.62. Alright, let's go fill these in. Okay, B, 0. C, at most 6 minutes. We decided that was, what did, okay, 4 decimal places. Alright, I'm on C. 1 divided by 5 is obviously 0.2. I don't know that I have to pad 3 more zeros in here? I don't think I do. We'll see what it does. And if we have to go back and pad them, you do get more tries on it. Okay. And we know that D was this one. Okay, so let's see what happens. My Alpha Math is pretty picky on its decimals. So 0.2. Okay. And then we're looking at D, which we said was 0.38. Now you have to remember that these numbers are random numbers. So it may be that when you divide them out, you're not getting nice 2-digit numbers here, or 2 decimal numbers. You're getting 5 or 6 that you have to round. But we'll see if we have to, 0.62. If we have to pad those zeros in to get it to the 4 decimal places. Okay, looks like it took it okay. Let me know if you have any questions. Thanks.